triangles, and then we want to look at some ratio word problems. Ratio word problems, still the easiest thing to do. A ratio is a comparison of two numbers. Set it up as a proportion. My personal feeling of the easiest way to set it up is a box diagram, cross multiply and divide. So if we look at it, this particular problem, the ratio of Arabians to mixed breeds in the herd was 2 to 17. If there were 380 horses in the herd, how many were Arabians? So you just set it up as a box diagram and then cross multiply and divide. It would be nice if you would label off to the side. If you don't label off to the side, some of you aren't labeling on the problems we've been doing already as box diagrams, and then you're struggle a little bit with which value to find. I don't know. We did or didn't. Probably didn't get through all of them. If you want to stop in and look at a couple of them, let me know. So you have Arabians to mixed breeds. They give you those, the way that the numbers appear are in the same order that the words appear. So Arabians to mixed breeds was 2 to 17. So how many total horses? 19. So we put our total down, and then it says if there were 380 horses in the herd, what's 380 referring to? Total. So if there were 380 in the herd, how many were Arabians? So your proportion is 2 over 19 is equal to x over 380. So you cross multiply 380 times 2 and divide by 19. 19 goes into 38 twice. So you get 20. 20 times 2 is 40. So there were 40 Arabians in the herd. Some of you just might notice it instead of cross multiply and divide, you might see that this is just 20. So you multiply by 20. You're just coming up with equivalent fractions. What is 2/19 with a denominator of 380? Clear back in the day, you used to do this before they told you that you would cross multiply and divide. I say so too. Another way that you can use it is science oriented. If you take a look at this example, it took 600 kilograms of sulfur to make 300 kilograms of the new compound. So if you think about a box diagram for this one, to make a new compound, obviously you're going to add something to sulfur. So we have sulfur, and then we have other material that we're going to add to that, and that's going to give us a new compound. Does that make sense? All right, so fill in the boxes. It took 600 kilograms of sulfur to make 3,000 kilograms of new compound. How many kilograms of other material would be required to make 4,000 kilograms of the new compound? So the information within the problem is filled in the boxes right now. I'm guessing you want to find this value first by just subtracting. So this would be, I think Wilson said it, 2400, 2400. So how are you going to solve? Cross multiply and divide. You do not need this right here, do you? So you're going to take 4,000 times 2400 and divide by 3,000. I would get rid of these zeros. And then I would say 3 goes into 2400. 800 times, and 800 times 4 is 3,200. So you would have 3,200 kilograms of other components that you would need in order to make 4,000 kilograms of the new compound. Question? I don't know if you've encountered any like that in science or not. Physics. Have you done the chemistry part of physical science, or is that what you're in right now? Oh, you're in biology, that's right.
That was last year.
Last year. Another example, the ratio of male factors to good guys was 3 to 11. So you have male factors to good guys was 3 to 11. If 350 individuals were investigated, where does that go?
Bottom right.
Bottom right. 350. So that's the total number of gentlemen that we are looking at. What is the total in the first column?
14.
14. They want to know how many were male factors. So once again, you're just cross multiplying and dividing. So that 14 does actually go into there, but 7 goes into both of them. 7 goes into 14 2 times and into 350. 50 times, 2 goes into 50. 25 times, 25 times 3 is 75 male factors. You've been doing cross multiplication and division with box diagrams for a long time. Yep. What did he say? Oh. I'd have you do this one on your desk, but by the time you get markers, I could just throw it up here. Took 800 kilograms of sulfur to make 4,000 kilograms of the new compound. So you're going to have your sulfur, your new compound, 800 kilograms to make 4,000 kilograms of the new compound. How many kilograms of other materials? How many kilograms of other materials to make 5,000 kilograms of the new compound? Question on where those values come from. Helps if you label. What goes in this other box right here? Try 3,200. 3,200 plus 800 is 4,000. So we're going to cross multiply and divide. Again, some of you make this difficult calculation. Get rid of your zeros. And 4 goes into 3,200. 800 times, and 800 times 5 is 4,000. Yep. Could you, if you wanted to, look at this. You had 3,200 over 4,000. How does that reduce? 4/5. 8 goes into 32 4 times, into 45 times. So you have 4/5. If this is a 5,000 right there, what's this got to be? 4,000. This reducing this right here is the same thing you're doing right here, in a way. When you're simplifying it. Are you okay with that? Similar triangles, the angles. If I told everybody to create an isosceles right triangle, I might have different sizes, but I would have isosceles right triangles. These two triangles are similar to each other. Similar because they have the same angle measures. If I look at it, each one has a right angle. So this angle right here is the same. If I slide this up, you will notice that this top angle measure is the same in both triangles. So obviously this third angle measure is going to be the same. But the side lengths of the sides are different. Angle measures are the same, but the sides are different. So they are similar triangles to each other. Similar triangles, then you have the same angle measure, but the side lengths are different. And when we talk about those side lengths, the side lengths are proportional to each other. Proportional just means you set up a ratio. Cross multiply and divide, and you have your answer. So everything in this lesson is cross multiplying and dividing. Yes?
So if you have one triangle with 90-degree angles, or one 90-degree angle, would another triangle, 90-degree angle, always have like the same angle measured on all three corners?
No. Just because you have a 90-degree angle doesn't mean that the others will be the same, because you could have a 30, 60, 90 triangle. In this case, this one is a 45, 45, 90. But your triangle could also look like, instead of being one where these sides are the same length, and you have 45 and 45, there's a good possibility you could draw one that's 90-degree angle but looks like this, where you have 60 and this could be a 30-degree. So yeah, just because there's a 90-degree doesn't mean that the other angles will be the same. But if the angle measures are the same, then your triangles are proportional to each other. The side lengths are proportional to each other. So if you look at these two triangles right here, all I did was I took one and I copied it, and then I blew it up. The same thing you would do if you took a square, took it into the copy machine, and enlarged it 200%. If the side length was 2 and you enlarged it 200%, the side lengths would now be 4 of your square. So we look at this, and if they want to find x and y, you just have to go with corresponding parts. First of all, these are similar triangles because I know that the angle measures are going to be equal. So we have corresponding parts are going to be proportional when we talk about the side lengths. So if I talk about the small triangle, if I look at the small triangle, the side lengths are 3, x, and y. What corresponds to side length x over in the large triangle? 5, because it's between the triple and the double tick mark angles. So x corresponds to 5, 3 corresponds to 4, and y corresponds to 7. They are proportional to each other. Similar triangles, the sides are proportional to each other. If I were to cover up the x and the x over 5, you have 3/4 equals y over 7. How do you find y? Cross multiply and divide. So what is y equal to? 7 times 3 is 21, and you divide by 4. Cross multiply and divide. Give your answer that way. What is that approximately? 5 and it is 5 1/4. So y is 5 1/4. If we look at x, what is x going to be equal to? 15 over 4. Cross multiply and divide. So what you're doing is you're forgetting about this one over here. So cross multiply and divide, you get 15/4. Raining utensils here. So you get 15 over 4, which is what? 15 over 4 is 3 3/4. 3 3/4. Now here's what should be true. Corresponding parts. So the smallest side corresponds with the smallest side. The largest side corresponds with the largest side. That should be true. And if not, you've done something wrong. This cannot be 3 3/4. It's got to be greater than this side length right here, because 7 is greater than 5. You can leave them in improper fractions. I'd leave them as that right there. The only thing I wanted to point out is just corresponding the lengths. So if you look at this one, I would take the smallest triangle. You have 4, 5, and 6. What does 4 correspond to? 9 is between the double and the triple tick mark. 5 corresponds to A, and 6 corresponds to B. It does not. Last time, I specifically put it so a variable was on each side so I could just cover up a fraction, and what you had to solve were right next to each other. This one, I put in increasing order because B has to be greater than A, because 6 is greater than 5. So this time I put them in ascending order so that you could see that with A and the B. That's the only reason. So what do you do to find A? 45 fourths. So A is equal to 45 over 4, which is 11 1/4. What is B equal to? Well, now I got to cover up the middle one. So it is 54 over 4, but we need to reduce that. 54 fourths is the same thing as 27 halves. So you're going to go 9 times 6 and divide by 4. 54 fourths. 27 halves. And 54 fourths or 27 halves is greater than 45 fourths. So it's in ascending order. No, you just have to tell me A and B. I just want you to realize that association. Corresponding part to side A has to be the longest side. Well, longest side here has to be longest side on that. Okay, are we good with that?
Yeah.